And welcome to Ladyada.
Hey everybody, and welcome to my desk. It's been a great week. We had a lot of people visiting from out of town because of Hope, and but we're back at our desk, ready to do engineering and electronics. Do you have any updates, Mr. Ladyada? Or?
Yeah, I mean, for super fans who follow the site and our shows and everything, if it all works out, Adam Savage will be on our show and tell Wednesday at 7:30. So yeah, I'm just like dropping it higher. So he's going to be talking about Silicon, which is a event out in California, and Makerverse.
Yep.
So if it all works out, it's always hard to time these things, but if it were, we'll let everyone know. But if you're around and you want to see Adam talk about this cool event, it's the closest thing to like a Maker Fair. Lots of familiar faces are going to be there and more.
And out in Silicon Valley. Great if you're in the California or West Coast area.
All right.
Okay,
so,
cool.
Check it out. And, other things going on and more, but that's the kind of highlight of the week.
Okay.
So, what is going on at the desk of Ladyada this week?
All right, let's kick it. Okay, first up, let's talk about revisions. Okay, so let's go to the overhead, and I'll show off a board that I'm revising and why. Hold on, let me get this all set up. Okay. The Metro Mini is one of my favorite boards. I actually use this all the time, mostly because I find it easiest to write drivers for the Arduino Uno first and then to other platforms. Partially because the compiler and uploading for the Atmega 328 is kind of like the fastest, and because it has a separate USB serial, I can press reset and I don't have to worry about the serial port disappearing and reappearing and the enumeration. So it's kind of nice for debugging. Doesn't have a lot of memory, but also it's like the standard Arduino. This is a breadboard friendly version of the Metro, so it has all of the pins that you would expect for using an Arduino compatible. Let me see if we can get this to lock. It's got the Atmega 328, LED, RxTX, CP2104, your serial USB to serial converter. Micro USB, 3-volt and 5-volt regulators. I mean, it can't give you 2 amps like the Arduino Uno peak out of the 5 volts, but you can do a lot of breadboarding, and you can see here I have this often wired up to STEMMA QT board as I'm working on it. So good news, love this board, and we actually have quite a few in stock. We did get Atmega 328s and CP2104s, and we were able to keep these in stock. But the CP2104, as we've mentioned many times on this show, is slowly being, discontinued and being replaced with the CP2102N, which requires a resistor divider. So I've been slowly going through all of our designs and making it so you basically can use the CP2104 or 2102N or the CH9102, that WCH USB to serial chip. Although I still like the CP series the most. So that's all good. So this board, wasn't in a rush to get designed, but it does need to get designed. And one of the things that I was actually, I've been working on some drivers this weekend, and I was getting kind of annoyed of having to plug in a STEMMA QT cable like this to do my my very common STEMMA QT drivers. I really wanted a QT port at the end. And I was like, if I'm going to do that and I have to redesign anyways, I might as well do a gut renovation and kind of tear everything out and start over. And so I designed a new version, the V2 of this board, which looks like this. And I'll show the difference. So, it's the same size, same pinout, mounting hole, same location, GPIO in the same location, but a couple things moved around. So one, I moved to USB-C because that's kind of standard. People are, expecting. I'm trying to make it so any new boards, unless there's a really good reason, I go with USB-C. And a lot of 0805 parts got shrunk into 0603, and these LEDs are 0603 now, so you can see they got shifted over to the left. The regulators are the same. I have the resistors for the USB-C and the resistor divider for the CP2102N, so again I can swap between the two parts. This main chip looks smaller, and it looks smaller because it actually is smaller. This is the 32 QFN version of the 328P, which is our standard bread and butter Atmega 328 chip. But because of the chip shortage, all those Atmega 328 QFNs have been allocated. Like we've used them in production. And so in order to get this design out, I actually was able to find, Microchip actually had a couple thousand of the 28 QFN version of this chip available. And the 28 QFN doesn't have the extra A6 and A7. There's 2 extra analog pins. And, there's just like one less ground pin. I mean, there's still ground, but it's just you don't have like 3 grounds. You have like 2 ground pins or something. So it's otherwise pretty much the equivalent chip. It's just a 28 QFN instead of a 32 QFN. So a lot of people don't use this package. They use this one. So this one I think was available. It's one of those like weird things where the package was available. The different package was available. So I snagged them, and I'm going to release this with the 28 QFN, and until I get through the 8,000 pieces, and then I can always revise it. I made sure that there's space. I could make it fit this bigger chip. And then you can see with the space I saved, I've got a STEMMA QT port at the end there. Yay! And the STEMMA QT port, the design decision I made to drop my oscilloscope probe is, because I was chatting with Mr. Ladyada about this. We have to make design decisions. So STEMMA QT boards all have level shifters in them, so you can use them with 3 volt or 5 volt logic. And they all can work with either, but Quick boards only work with 3 volt logic. So the only thing is, that needs to be done is, I didn't really have space for a logic level shifter, and also I didn't want to put pull-ups on the I2C lines because those are also analog pins. So on the bottom, the silk screen's actually, I forgot to have the silk screen, but you have to change the logic level from 5 to 3 in order to use the STEMMA QT with 3 volt only. But I think it's not a big deal. I do it all the time. I think this board has, it'll say, it has the VIO silk screen, so you can see it's default 5 volt, but you can set it to 3 volts, and then you could run this whole thing at 3 volt logic and power. So, pardon me. So this is a new board, and I'm using this, and it's super fun because I can just, plug in a sensor, and I can start coding for it. So this is a UV sensor that I'm going to work on a driver for. So that's cool. So that's one board that I finished, and I ordered the PCBs, so you'll see that in the shop in a couple weeks. It'll be a new product ID, because I do think that there's some people who, they do want to have, the button did move, and, we still have a bunch of these in stock. So I think people can choose which one they want. I think there's reason to carry both for a bit, because it's a pretty big redesign. So that's that. Is there any questions before I move on?
No, there was CP2102N for new version. I don't know if that's a question or if it was just they were...
Yes, we're using the CP21. Well, either CP2102 or 2104.
All right.
Okay, so the next thing...
Keep going.
Yes. Oh, I dropped my... so next thing I've been working on, which, it's one of those things where, like, I kind of made a joke. I was working on, like, a different tester, and, like, how you're just like, oh, all I have to do is update, a version of, like, Raspbian on a tester, and then before you know it, you're installing, like, WSL v2 and, like, messing with your BIOS. So I'm playing with this sensor, which I dropped. Hold on. It's a very weird... Uh-oh, I lost it.
What?
Hold on.
What's going on here?
I made a little under attack. I dropped my sensor underneath.
Do you need a flashlight?
No, but it's like, it's stuck in the worst place. Hold on. Oh. No.
Well, how about I get it in? Why don't you? Okay.
Got it. And not only did it fall underneath, it fell underneath like the...
Stay tuned for Under the Desk of Ladyada, a new series that
it was like under the desk leg, and it was like caught in there.
We'll start that series soon.
So this is this is kind of an interesting sensor. This is called the AGS-02MA, and it's by the same company that makes the DHT-22, which is why it looks like a DHT-22. But it's actually a gas volatile organic compound sensor, which I thought was interesting. Like, look, it's cheap, right? It's a cheap gas sensor. It definitely, like, works, but it's not what I would call, like, a high precision sensor. So I've got it hooked up here, and then it does require external pull-ups. So let me wire this up like so. And then I had this hooked up to, hold on, man, there's just disaster everywhere here. Okay. Got my sensor. I was hooking it up to my Arduino, on my Metro Mini. And the thing that's interesting about this is that, it does work. You can read the gas resistance. Inside is actually a little microcontroller. It's like a little, 8-bit micro. And it reads from an analog gas sensor and converts it to I2C. The thing that's really annoying about the sensor is it requires a 20 kilohertz I2C clock, which is really low. Most things are 100 kilohertz. And when you set the clock for most chips, they expect you to go only higher than 100. You go up to 200 kilohertz, 400 kilohertz, or even 1 megahertz for I2C clock. It's not very common for microcontrollers to set their clock rate to below 100. And so, for example, as I was doing this, it's I just want to read the sensor. Before you know it, it's it turns out the Arduino core doesn't do the prescaler right, so you can't use the low clock rate. And then I was okay, I'll do the PR for that. And then 2 hours passed, but I did get this sensor going. So let me hold on. I have to get the right port. Maybe. I might have to re-upload the code. Okay, so, can you go to the computer? So this is there's just a little bit of I2C debugging, but you can see the gas resistance and the total volatile organic compounds. It's about 400 parts per billion. And then, if I take my handy dandy rubbing alcohol, isopropyl alcohol used for cleaning off floppy drives, and I just kind of waft the cap over it, you'll see in a few seconds the total volatile organic compounds spike up to, 12,000 or 50,000 parts per billion. So it is reactive. I would definitely not use this for anything more than just overall trends, rather than trying to actually, use this as a calibrated source. It's definitely not a scientific source for organic compounds, but it gives you a rough idea. If there is alcohol gases in the area, it will, methane or ethylene or whatever, it'll probably detect them and give you a sense that it's gone up or down. But I did have to do a bit of work to get the set clock function working. We also have a CircuitPython library, and then it turns out that some chips actually it's just very challenging to get them to clock at lower than 30 kilohertz. But luckily, ESP32 and AVR 8-bit did work out after a little bit of a tweaking. So that's good, and so I'm going to finish up that library tonight, and then we'll have these sensors in the shop so that people can use them. And I think it's, I can't help it. I love little I2C sensors that even if they're cheap, they're great for students. I can definitely see a lot of kids in school that are I want to make a basic, how does the breathalyzer work or whatever,
Yeah.
or how does, a gas alert sensor work. You could prototype it for a couple bucks because gas sensors can be kind of pricey.
All right, you want to do the Great Search?
Okay, just if there's any other questions.
No, keep
Otherwise,
going.
let's go to the Great Search.
Where in the world is that part I need? The Great Search with DigiKey.
The Great Search brought to you by Adafruit and DigiKey. Thank you, DigiKey. This is the weekly segment where Ladyada uses her power of engineering to help you, yes you, find the things you're looking at and for on digikey.com. Ladyada, what are you looking for this week in the Great Search?
You would never guess it, but this one has to do with a part that I can't get anymore.
I bet.
Due to the part shortage.
I bet it has something to do with parts.
Oh, good guess. It does. So this week, we are, what's interesting is half the time you can tell I do a part shortage because I'm like, hey, I'm designing a new thing and I got to spec a part. And the other half is I'm told by the fabrication team at Adafruit, they're like, hey, like, we can't get this. Or the purchasing team says, this part went end of line, we can't get anymore. We need your help to find an alternative so we can keep production going. So this week, the part that I was told is no longer available. Because again, not only is it hard to get some parts, but parts that are available are going end of line much faster, end of life, and they're not, non-cancelable, non-returnable, which means they're kind of nearing the end of their functionality life. And so, finding a good alternative for this part, the fan 5333, even though there's a last time buy, I haven't learned my lesson. It used to be last time buy meant you could actually last time buy. Does not mean that anymore. It means like it's over. Good luck. Maybe we'll send you some in 2 years. So this week we're going to let's go to the computer, and I'll show the part that I am getting. So the part that we're going to get is the fan 5333B, and I love this part, to be honest. It was a high current 1.5 amp internal switch, fast 1.5 megahertz switching frequency, super small, inexpensive, SOT 235 boost converter for LEDs. And what's cool about this is that it was a constant current LED driver, which means that, if you're dealing with backlights, so oftentimes, you get a TFT, anything that's kind of big like this, like anything that's over like 3-inch TFTs, the backlights are often in parallel. So let's look at the backlight diagram. Hold on. Okay, so this is the display, and there's the pinout, and then when you look at the backlight, it's like, bam, you have 6 or 7 LEDs in a row. You want to drive them to 20 milliamps, but you have to, the V forward for the LEDs is 22 volts. And this is not uncommon. Most large displays require a boost converter to drive the LED backlight. And the V forward, of course, is dependent on, if you have like one LED, you can use a resistor. You don't have to do constant current because it's like, it's 3, it's 3.4. It's somewhere around 3-ish volts. But when you have a bunch in a row and there's variations in the backlight design and variations in temperature and, whatever, how bright you want to run it, that VF it says 21.7, but that's not guaranteed. It can really vary from 20 to 24. So having something that's constant current, you set it, look, I just want 20 milliamps, and you boost it as high as possible to get to that voltage. That's what you want a constant current driver for. And that's what the fan 5333B did wonderfully. I loved it. So up to 30 volts. It again did 1.5 amps, because let's say you had 24 volts output divided by 3.3 volts input. So it's a 7.5 times multiply. And then let's say you had a 0.05 amp output. So you need at least 400 milliamps, 0.4 amp current switch. But honestly, I would really double it. You really want, at least 750 milliamp internal switch current, so you don't overload it. And also, if you need a little bit more, like 75 milliamps, you can do it. So this was a really great driver, which is why it's so tragic that it's not available. So let's look at what it used to be. Here we go. Last time buy. This is it. End of line. So let's find an alternative. And I will say it's a little challenging to find a perfect alternative, but I'll do the best I can. And another thing is the price was really nice. These are about 60 cents a piece, which is like really sweet. So you do need an inductor, you need a diode, and these also needed a protection diode. They would actually, they need a Xeno diode to avoid going over voltage, but those were cheap. Those were 10 cents. So not bad. So let's find something similar. Again, from 3 to 5 volt input, 24 volt output, switch current of at least a half an amp, but as much as possible, high speed, PWM and ideally the same size and pinout. Wouldn't that be nice? So let's find something. It's a DC-DC regulator. It's a step up with internal switch and one output. I'm not going to set the voltage input min max because of course it could always be a wider range, but also I'm a little flexible on it. Voltage output, again, I don't need up to 30. I just need around like 20. Current output, I'll just see what's available. I do want surface mount, and I don't pick the package case because remember there's SOT 23.5 and there's TSOT 23.5 and both will work, so I don't set this and I set this on the next page. So, all right, here we are. So let's look for only active items because again, we don't want to find things we've already found. Next up, we do want to set the package. So I'm going to go down here and I'm going to select SOT 23 thin or TSOT, which is also the same as SC74A. I'm like pretty sure that was the one. It's not the same as 70. Yeah, 70-5 is the smaller version. 74A is the same as TSOT 23.5. I will say, by the way, because, obviously I do these, earlier because I get it all ready to make sure I can actually find something. There is a lot more options if I'm willing to go to the TSOT 6. So I will say, if there might be some situation where I'm like, oh, if I have to update the design, there might be there'll be more and better options if I'm willing to go to a 6-pin SOT 23.6. But again, I'm looking for something that could swap into my current designs to just let me stretch out the PCBs I have now. So let's look here, and this is already only 35 options. So I'm also going to look for stuff that's in stock right now. I will say that there's a couple options that are not in stock, but if it's not in stock, a lot of them aren't coming into stock until 2023. And then the voltage output, I will say, I didn't want to limit this because some of them, they were like voltage output, but they could actually go a little bit higher than 20 or 21 volts. Also, the current output, because some of these are switch current and some of these are non-switch, I was like, you know what, I'll just look at the data sheet for each and see what's up. Next up, search by price, because I want to kind of get something close. So the first thing I'm going to look at is this like ZXLD. With boost converters, you really do have to just look at the design. So the only thing is that this is actually kind of weird. It is a backlight driver, but it's actually like a cell. It's for a photocell, photovoltaic cell input to an LED. So it's a funky, useful thing, but it's not what I want. It's not the kind of boost converter I'm looking for. Next up is the NCP 5007, also a pretty good price, about the same. Looking at this, okay, so this looks promising because this is, you can tell it's actually a boost converter and it's meant for a string of LEDs. It can do up to 22 volt output, which is a little bit low, but I think it might work fine for most of my designs because remember it said about 22 volts output. Let's look at the current. It can do 1.0 watts, which is, if you divide by 22 volts, about 45 milliamps. So, yeah, not too bad. The only thing is I looked at this one and I looked at this and you see it's switch, ground, feedback, and this one is feedback, ground, and so it's not the same. It's the same package, but it's not the same pinout. So, that doesn't mean I'm going to say no to it because I could reroute some traces. I could still use the same pick and place program, the same stencil, but I'm not loving this one so far. All right, next up is the CAT 4139. This one, looking at switch, ground, feedback, and this one does switch, ground, feedback, shut down, VA, and so this has the right pinout, which is good. It has the right package, which is good. It also says can drive lines up to 22 volts. But when I looked, yeah, I'd like to have 22 volts, but it was actually willing to do a little bit above, I think. I remember I saw it was like, oh, you know, you could go to, there's an old over voltage detection at 23 or 24. So depending on the displays, it might actually be okay. And then the switch current is 750 milliamps. Remember, you've got to like, that's the multiplied current from the input. So that would mean, let's see, 22 volts divided by 3.3, which is like 7 times. So 750 divided by 7. So max 100 milliamp output, but really I'd say 50 milliamps is probably good. That means 2 parallel strands, which for that 4.3 inch display, it only had 1 strand, but the 7-inch displays we have 2 strands in a row. So that's good to know. And it has some open LED detection, and it has PWM control. So the only thing that was a little odd is it wanted a little bit of like, it had a resistor here to protect the feedback pin, but it wasn't clear if you actually needed it. The feedback resistance is a little different, so this uses a 0.3 volts feedback, and I believe this one uses, oh no, it also has about 0.3 volts, so that's good. The feedback resistor is the same. And you can PWM the input. No more than 2 kilohertz, but it is PWMable, which is what I would do for our design. So I would use that for that's how you PWM the LEDs. You actually just like turn on and off the boost converter really, really fast. So will this work? I mean, it doesn't go as high. It's not 30 volts, it's 22 volts. That said, I think given the small number of items in stock, like after this, the price gets really high, and like this boost converter is only 350 milliamp switch. And then it's like, okay, now the pricing gets quite high. One chip that did look like it was a very good option if the CAT 4139 doesn't work is the MCP 1664. This goes up to 36 volts and a 1.8 amp switch, so it's a really good output. And I think switch ground feedback. So this is also pin compatible. The only thing is it's twice the price, but it will definitely do the job. It does that voltage or higher. It does that much current or higher. So it's kind of an upgrade. So we've got 2 options. I'm probably going to try this one for some of the smaller displays, like again the ones that only have 1 strand. But if I need 2 strand or 3 strand, something that really wants to push a lot of current or high voltage across the display, I can always go to the MCP 1664. So 2 options, but I'm going to probably start with this one, the CAT. We'll go back here, the CAT 4139, and there's a couple thousand stock, so I can pick these up and then see how they do in the design. And of course, I'll know immediately if it's not lighting up the backlight or if there's any issues. So I'll probably pick some up, hot air them onto the backlight controller for some of my displays, and just like, do they light up bright enough? If so, we'll be able to use that. And I'll just check each display one after the other. If it doesn't work with this one, I'll try the MCP as well.
All right, that's a great search.
Where in the world is that part I need? The great search with DigiKey.
All right.
Okay.
That is the desk of Ladyada tonight.
That's what I got.
And we'll see everybody throughout the week. Thanks so much for joining us on this Sunday Eve. We shall see you next week.
Bye, everybody.